Thank you, Henrik, for giving me the floor. I would like also to thank the organizers and the Sirius Space Institute for allowing me to present this, my work, which is also a small piece of the research I'm doing regarding satellite commercial uses regarding imagery and data. Well, as Henrik says, my job is an attorney. I'm an environment consultant. But however, my mission here is to raise awareness and to raise consciousness regarding how the GEOSS, the system of systems regarding Earth observation and what it's doing and in which regard regarding environment issues, and of course the interrelationship with INSPIRE. So I guess I only have like 10 minutes or so. So as I said, first of all, I will refer to GEOSS so we can understand more or less what GEOSS is. Also, the interrelationship with INSPIRE, with the directive, the 2007 directive regarding environment, and also what lessons I have learned and a potential future perspective in this regard. Okay, as I was referring to, GEOSS stands for Global Earth Observation System of Systems. The INSPIRE directive is a standard and harmonized and uniform legal instrument that intends to create standards regarding technical metadata and other parameters such as network and data sets, as you know, and regarding the use of data that can be spread and used and commercialized all over Europe with no bumps, no implementation gaps or whatsoever. So in this regard, I was doubting at the beginning, what is the nature of GEOSS? I must say that GEOSS doesn't have at all legal personality as far as I know. So it's an initiative formed by at least 100 legal persons, among which are countries, governments, institutions. So I checked today the Group of Earth Observation website just to be as updated as possible regarding how many members. I saw 102 or 103 members. But what I would like to say is that regarding environment, we are actually too late, because it's not time to raise awareness or to make people understand what Copernicus is. It's now time to implement real and concrete applications to protect environment and to start obtaining the result out of it. Because in my case of my field of study, marine ecosystems cannot hold any longer. Actually, I will refer afterwards to a study that was published in the Science magazine. So what is behind GEOSS' intention? As an initiative, GEOSS intends to foster monitoring and Earth observation and remote sensing activities by satellite, and also ensuring data access. Data access indicated and addressed either to individuals or companies or governments in this regard. I will also make a statement regarding the INSPIRE directive, which along my study has helped me to find the weak spots. Because I'm not here to say how great INSPIRE is, I'm here to say how we can improve INSPIRE to be better. So GEOSS understands data as public good. I understand also data that, apart from being public, should be free and open to everyone using such data for a legal purpose, at least for an environmental concerned purpose. Also, as I said, GEOSS represents a collaboration and integration of different individuals, persons from all over Europe, I should say for all over the world, because now with internet, commerce is not local, but global. So about GEOSS, I have to be brief. So I have divided my study and my future activity in three fields, three arms, I would say: legal, technical, and institutional. So we have to perhaps stop working on environmental codes and laws, which we have already too much. We have one maritime planning directive from 2014. We have one marine strategy framework directive from, I guess, 2008. We have the INSPIRE directive from 2007. But at least the impression that I have is the whole thing remains up on the highest grounds in the scale. So it's time to start doing something once for all. Technical, that's the real thing. Before I was talking to one of my colleagues about Horizon 2020. Horizon 2020 is an initiative fostering spatial data solutions from space to users. So we need to use and take advantage of such benefits that we are being offered by the European Union just to protect environment once for all. Institutional, we need to create groups and lobbies regarding how we can protect environment more and more. We need to foster the environment protection not only from a urban, from a earth, from a catastrophe planning, but from a sea and maritime. Because I will just refer to an impression that I got. I was also telling that in a conference in the other room. There was a lot of people in the main room concerned about Inspire. What does it work for? It was the main session. In the marine session, there were only 20 people. So this is not enough. We should make an effort, a more intensive effort in this regard, regarding environment. Not only, I even heard one of the speakers that referred to Inspire as how to make the quality of water for tourists better. I mean, this issue, I think, is no longer important. It's more important how to take care of our waters, take care of our environment and Copernicus data, which is capable of being transferred and downloaded by users. So Copernicus, I'm sure you know, deals about biochemistry, temperature, ice melting, and also current tides, and as I said, temperature. So Copernicus is concerned to not only prevent environment marine impact from companies exploiting the marine ecosystem, but also to take action against, because we have a directive in Europe stating that in case of environmental damage, the damage has to be redressed and restored up to the point it was caused before the damage that was caused by a company in this regard. So as environmental damage is concerned, it's very important to know and to understand the notion of an insurance company. Insurance companies have a key role regarding marine and damage and ecosystem restoring and taking all things as it was before. Because, for instance, we have a directive called Marine Strategy Framework Directive that refers as 2020 as the deadline where all the actions have been taken to restore and take all the situation as I would say in a sustainable and proper situation, as if we could use from scratch the sea as if nothing had happened. So enough saying that. So I'll refer to the weak points I found regarding GEOSS and Inspire. So as you probably know, the Inspire directive, there are, as far as I understand, 34 special data sections, and regarding the annex, we have Annex 1 and Annex 3 regarding marine ecosystems. It's all explained all over there. I won't get into that. You have Inspire directive as a reference. But again, there's no reference to consumers in Inspire. If you check if Inspire mentions the word consumers, it does not appear for a reason. We have a weak party to solve. Lessons learned. So I think I've mentioned them all. But so we have to foster marine environment applications. Obviously, technical issues has to be addressed, but if we are living in a realm of data harmonization, KMZ files or KML files or XML files have to be capable of being downloaded with a minimum time delay. Data shall be free, and also we have to find better environment protection, as I say, towards this new type of online contracts, which I referred to just briefly, which are called shrink wrap, browse wrap, and click wrap contracts. In this regard, Recital 8 of the 2014 Copernicus regulation referred to as the importance of the group of Earth observations, and we have this Copernicus Marine Environment Monitoring Service, which is now substituting, starting from May 2015, the former MyOcean program. So, lately, just to make a conclusion, how can we envision, or how can I envision Inspire using this data to protect other fields apart from I'm sorry, I don't see Inspire in other fields. I see Inspire just preventing what the real problem that we have. I read in this September, I read this September an article in Science magazine referring to the extinction of marine mammals, which is the 6th large mammal and animal extinction that is happening in planet Earth. So we have to use satellite infrastructures to prevent this thing from happening. So I asked that question, I think the day before yesterday, and I received the answer saying we're not here to save the world, but it's useful, Inspire. Well, I'm sorry, I'm not happy with that answer. We have to use Inspire to create concrete measures. We have to foster Annex 3 regarding satellite and marine ecosystem, and we have to make it happen. It's not enough trying, we have to make it happen this time. Thank you so much.
Thank you very much for an interesting talk about some very important initiatives at the global and European level. Copernicus is also a very important contribution to GEOSS, this is really relevant. So I think considering that we will have 6 presentations, I will allow 1 or 2 questions now, and of course we can continue after the presentations. But is there a question? Okay, so maybe there will be a question later, and we can take it at the end of this session. Okay, thank you very much, Jordi. So the next presentation will be by Erwin Goor, who is project manager at VITO, remote sensing, and he works with focus on data distribution and exploitation, and his talk is about mission exploiting platform for PROBA V. So we will try to find the presentation somewhere. And it will start. Okay. Yeah, so please.
Okay, thank you, Hendrik. So just to mention that VITO is a Belgian research institute where we have a substantial remote sensing department. So the mission exploitation platform PROBA V is an operational service which we are setting up and operating on behalf of ESA and the Belgian space policy. So the sound was not prevented, but okay. PROBA V is a Copernicus contributing mission. It's delivering every day a complete image of all land masses worldwide, every day. At 300 meter resolution and every 5 days at 100 meter resolution. And VITO, let's say, developed and operates now the EU segment on behalf of ESA, and this is one of the Copernicus contributing mission optical data for spectral bands. Now, this is the time series of data. I mean, the amount of data which is sent is 150 terabytes per year. It's not that big data, but if you consider that people need a time series of data, and also before PROBA V we had spot vegetation 1 and 2, so it's a time series since 1998 of daily data, and therefore we need to take measures to make this data exploitable by the people. This is the scope of the project. But so today we stopped by producing and distributing the data, and we want to add now, or we have added a component, an exploitation platform next to it. This is the scope of the mission exploitation platform, but I want to highlight you as well that VITO is the prime contractor and the major distributor for the Copernicus Global Land Service, and here again we can reuse specific components from the mission exploitation platform to increase the exploitation of these data as well. Now, what is a mission exploitation platform? So the idea is to bring all the data at the platform, PROBA V, because this is the data, but as well the precursor missions, and as well other data which might be used by people working with PROBA V, and as well derived parameters and so on. Next to the data, we put ICT resource, so CPU power, so that people can start processing the data without having to download one single byte of data. That's the idea. Of course, all tools, software which we know, open source things which people can use to work with the data. This can go from GRASGIS, QGIS, but as well GDAL to make really applications, Java, IDE, and so on. And then documentation, tools to collaborate, user support. So let's say we built a whole ecosystem for people to work with PROBA V data. And this is our means to let's say, to open up all this data by this exploitation platform. Of course, it's important to make to establish links with other platforms where similar data is. I think, for example, on platforms where we will have access to Sentinel-2 data. This is also used by our community, so we must federate with these. In the platform, so in the project, we developed the platform, we operate it. It's an operational service, not just an R&D project. It's really operational, and we support the users. Now, it's an easy look and feel, so it's operated by Vito at Vito, but it's in an ESA look and feel because PROBA V is, we make the service for ESA. And we have today already several applications, so let me quickly go through them. You must know that in these applications, we really tackle the whole set of users, going from end users with very simple viewers towards really developers. The first application is a viewer service, so you can click at the left, you can take some collection, a color composite and DVI, whatever, and on the top you can play with the date and you can select a specific date and then you see the image of that day. You can zoom in, zoom out, pen, whatever you like. It comes, of course, also with the WMTS service behind it for, as an API. We also link in some parameters from the Copernicus Global Land Service, which are derived from PROBA V. So here you can, for example, see a leaf area index and you can zoom in till the finest level of detail. The next step is this kind of application. It's a time series viewer, so you can click on a country or on a region, and then you see the evolution of a parameter over time in the charts below. You can combine it, as is shown, with rainfall data, with long-term average of rainfall data, and soon we will also be able to, that the user draws a polygon, and we extract this time series then for this all the pixels within the polygon. So this is a way of working, of viewing the complete time series of data. We also have these applications for the Copernicus Global Land Service already available for the major parameters. Next step is an NDaily compositor. I will not explain what it is, but it's just the idea is to have predefined on-demand processing service. So behind the platform, we have an Hadoop cluster, which is allowing us to do really powerful parallel computing, and we expose services where the user can define with a lot of parameters what he wants, and then he can launch the processing on the Hadoop cluster, and the processing takes then minutes, hours, days, whatever is needed, and at the end he will get an email with a link to download the results. This can also be scheduled as new data from the sensor is taken in, the processing can be started automatically. And then the next step is a virtual research environment, so a user can get a VM with a lot of tools pre-installed and with access to the full data archive and can just develop applications to make prototypes. And when these are successful, these can be, let's say, integrated in the platform as a kind of on-demand processing service, as I showed you before. We also have Python notebooks or Jupyter notebooks now, where you can interactively work with Python on the complete data archive. Very powerful, but not yet in operations. This will become in operations in January. If you're interested in that, please address me and I can discuss more about it. And then the last step is dashboards. So we are able to compose different dashboards with different components, a map, a chart, a table, and so on. And these are dynamic and all interlinked. So if you select a specific region on the map, also the charts will show the information for the specific region. So how does it look like? So below you have the complete archive of PROBA V, Spot Visitation, and also Copernicus Global Land. And on top of it, we have then Hadoop cluster and OpenStack cluster because the data is at Vito, so we have a private cloud built around the data. Then we have a lot of libraries, and on top we have all the applications. So if you look at the high-level component, you have at the right, you have the cloud, the private cloud, where we can give you a VM with the tools you need, or you can also install new tools. We have the powerful Hadoop cluster for doing some parallel processing, and we have at the top, we have different interface to the users, a web portal for human users, web services, and also remote desktop access for the VMs, of course. I will skip this for the sake of time, but just to say that we are also supporting users on working on Hadoop, which is not it's not easy, and there are different flavors possible, and we try to find the best way to work with Hadoop. This can go from just putting your application as is on the Hadoop cluster, from really designing your application again with Hadoop Spark for really the best performance. Just to mention that we are using behind the scene a lot of open standards like WCS, WMTS, also catalog service, of course, I didn't mention them here, but also a lot of REST interfaces for easy invocation by our applications. We started in November 2015. The first version was made in operations already after 2 months. And now, next week, we will declare the first real iteration ready for operations, and we will go with the new iterations live. And then we have 2 further developments. So it's just to say that if you go to the URL later on, please visit us again in 2 weeks, because we will then have something new operational, and also within 9 months later. Just to recapitulate, I mean, I think we are setting up an interesting tool, an interesting operational service. It's really operational. It's on relevant data, being a Copernicus contributing missions, and we are using for that all kinds of state-of-the-art tools which are known from the big data world. And this is keeping evolving every week, or every month. So we take on new components, we test them, and if they are ready for operations, we integrate them. We already have several users which are using the system, so this is just an overview of what they are doing on the platform. These are developing prototypes, developing applications on the platform without having to download a single byte of data. And of course, we are looking for collaborations on different aspects. If you work with PROBA V, we can collaborate, of course, but also if you have interesting tools, if you work on standards and so on. If you have expertise in Hadoop, in big data analytics in general, we can collaborate. Because for me, this platform is it's an invitation to collaborate with data owners, with application developers, and so on. So, because at the end, we want to grow to a kind of a geo-application platform via partnership. So it should not be an island, it should be federated with other infrastructures and so on. Now, coming back on the questions which the organizers asked me to address. First of all, heterogeneous sources. Well, it's clear that we are keen on linking data from heterogeneous sources. For example, we have rainfall data, temperature data. We also have, we used to have crop production rates from the FAO, the Food and Agriculture Organization, but unfortunately, this service has been stopped. And this is one of the weak points. You have to find services which can give you, in a very easy way, interesting data, but they should also be operational. If they stop after 2 years, you are stuck, of course, and you need to decrease your service level to the user. So having a lot of operational service is what we need. Also, federating with other infrastructures is a key point where we have to work on in the near future, and I hope the Commission will give us the ability to do that. And in situ data, well, it's also known, of course, that this is something to be tackled. For example, in another project which we are doing for the Commission, an FP7 project, Sigma, we already are building this kind of service. It's a service where we load some in situ measurements for agriculture, for let's say agriculture parameters. And we load them in a database, and you can click on the point, and then you see the evolution, for example, when the crop was planted, when it was harvested, and all the steps in between. Just to give you an example that we're also building on that. How was it done? So before that, the data was just uploaded via Excel files in an SQL database. Now we put a REST interface on top of it at a partner, and then we download the data in an Elasticsearch, and we are able then to query the data and to make this kind of nice interactive dashboards on top of it. Just to say that we are also working on that level. Second point, sharing data. Well, I think the Jupyter notebooks, which I briefly discussed, is an excellent way of sharing scientific results. You can do some Python scripts, you can see the results, you can save this and send this to a fellow researcher who can take it again and can change the parameters and execute it again. We also had a requirement for sharing dashboards, so people are working with the dashboard, they are zooming in, they are clicking on specific field, save this and send this then to another user, but we see that this is not often used. It's mostly that they want to export all the different components and to be used that in their report. So a full export of a dashboard is not always used, but the individual components is done, and then they copy-paste it into their reports. Lesson third in terms of compliancy, well, in terms of Inspire, well, I think we need easy-to-use APIs. It does not need to be complex. I mean, we need to think of machine-to-machine communication. If I have an application, I want to, without any human intervention, I want to discover data from a platform, download the data, and invoke directly my processing. So it must be easy to use. And Inspire is a clear stimulus here, a clear guidance, but sometimes we need to reduce the complexity to make it happen. Okay. what is recommendation? Okay, we need to focus on open standards, but easy to use. We are also adapting open search in favor of CSW, for example. And the exploitation platform, I think what we build up today for PROBA V can also be used for the Copernicus global land easily. So we should also take advantage of what we have developed in one service and bring it to the other services. And then the last point, how can this be applied in a completely different sector? Well, we have a completely open architecture. We are using solely open source components, so I think we are ready to address it as well for other services. This is the URL where you can find it out, and thank you very much for your attention.
Thank you very much. It's so interesting to see that there are more and more projects which are concerned with the fact that we cannot move around with very large data volumes, that we need to move the processing to the data. And this is really a good example. So, a question or two. Okay, in that case, I will take the opportunity maybe to ask one question. I mean, because we always talk about sustainable solutions and all that. I mean, and also in this case, what is the future of this exploitation platform? Is it sustainable also in the future? Because I can see that you now intend, if you're not already doing it, to include Sentinel-2 data, Sentinel-3 data, Sentinel-1 data, whatever. But what is the future?
Well, it's a mission exploitation platform, so it's dedicated for PROBA V. And as long as the mission will be there, we will also have the mission exploitation platform. So in terms of that, it's secured. It's whenever we will have a successor for PROBA V, we must renegotiate, of course, with the sponsors to have this exploitation platform as well. But I think in terms of sustainability, also Copernicus can play a viable role. As I said, for the Copernicus Global Land Service, for example, this is immediately also applicable. So here also we can set step first. So it's definitely one of the main topics which I have to deal with every day on sustainability, and it's a valid comment. But yeah, I mean, we live from project to project, and that's it. But at least it's an operational service, and it will be there as long as the PROBA V mission will be operational. That's already a fact.
Okay, thanks. Good. So we will move on with the next presentation. I will just find it. So the next presentation will be given by Dominique in Intelligence and Machine Learning, and he works at the Sheffield University Department of Computer Science.
So I seem to be a little bit away from the previous presenters in that I'm not really to do with the satellite imagery itself, but and I actually wasn't to do with this project itself as well. I'm here, standing in for a colleague of mine. But we'll talk about the Crowd4Sat project, which was a relatively small project which ended earlier on this year, and was to do with seeing whether you could overcome some of the limitations of Earth observations using crowd-sourced data. As I said, it was a small project, 14 months, less than 200,000 euros, and it involved 4 demonstration areas. So it was spread rather thin. It had 2 main tasks in the project. The first was just a general looking at the crowdsourcing domain and the sort of projects which were using crowdsourcing and how they could be used in combination with Earth observation. And then, as I said, the second task was these 4 demonstrator projects which tried to use crowdsourcing in them. And that'll be the focus of the talk today. At the end, I'll provide a link which is a report of the overall project, which goes through both of these areas. So the first of the case studies was looking at whether you could get snow coverage and snow depth. So as I understand it, one of the problems with using imagery is things when you get shadowing, it's very hard to work out whether this is snow covering, and also it's obviously quite hard to work just from an image, the depth of the snow. So the idea was to engage with communities who would go up into the mountains, so hikers, walkers, skiers, and to see if you could get them to provide some information on the depth of the snow, and then you could use that to correlate with the images. So this work did manage to get together with a few groups who were skiers and hikers in the mountains. We recruited around about 100 people who downloaded an application which would enable them to give us feedback, and by the end of the project we had absolutely no data whatsoever from any of them. So that didn't really succeed. And that's more of a problem with crowdsourcing, is that you have to find the right people, and you have to work out what their incentives are. So obviously when people go into the mountains to ski and walk, they generally like to ski and walk, and they don't get out their phones to take a measurement. Generally they're stuffed in their backpack, or whatever. So that was the finding of this, that are good of identifying people, not so good at identifying their incentives, or rather lack of incentives to provide data. So the second use case was traffic and pollution. Again, I'm not 100% sure exactly what was going on here. I know that I think it was the issue was trying to get the elevation that the pollution was made at, and so they wanted to use something to do with telematics in cars to calculate how high the car was travelling, and therefore they could use this to augment the maps and use that to work out how the pollution was being distributed. This was more successful in terms of the organisation which involves distributing this piece of equipment to measure the drivers and where they are, actually provides lower premiums for their insurance. So people are incentivized to actually use this tool and this data feedback because they get cheaper insurance. So in terms of actually getting data back, that worked. So to be honest with you, I can't really say how well it worked in terms of its initial aim, which was trying to improve the Earth observation data. That was the findings from that. The third project that they looked at was emergency flood mapping. So one of the problems is when a flood happens, it's obviously quite dynamic, and you want to know the extent of the flood. Obviously, it's possible to use this using the Earth imagery, but the amount of time it takes to get that imagery may take hours or days, and the people who want to respond to the flooding happening want to know the extent of the flood before that. So what they wanted to do was to augment the imagery data with data from social media. So can we get people to can we capture people's discussions of what's going on during the flood and the images that they post, and try to use those to see if we can work out what the extent of the flooding is. Again, this was kind of a partial success, but mainly to do with the use of social media in the fact that not everyone tells you where they're tweeting from, and they did get back useful information for knowing the extent, but largely this involved videos and pictures, which was okay if you could look at them and know where they were from, but also what we really wanted to do was be able to automatically process this data. So again, the problem is in we managed to get back the data here, but it wasn't in a form that we could readily process it automatically. And finally, the last project was trying to improve the definition of land use. So obviously this is a application with Earth observation has been used for pretty much from the start, and they want to try to improve the measurement of land use from the images. So the idea would be to get people on the ground to tell you what the land use and land cover was during their location. In this case, the user group that we used to get the data back was people who worked for the organisation. So I think the use case was in Italy somewhere. So it was, but basically the civil servants from Italy were given this application. And so they were basically told to provide this data, in which case we did get a lot of data back. So we were getting like 1,000 readings a day, which for crowdsourced data was very good. What we did find is that these people had difficulty in interpreting the classifications. So I think that the Earth observation data uses something like 44 categories to categorize land use, and it was really not clear to the people on the ground how they should categorize the land in front of them. And the other thing is they weren't also sure how far they should look. So are they actually categorizing the ground that they're stood on, or the ground around them, or the ground that they can see in the distance? So again, this was a success, but only to an extent. And the overall outcomes of this is that it is possible to use the citizens as sensors and to potentially improve the measurements from Earth observations. But obviously the problem is that they're not always available, and they are subjective. They're also motivated by various things, usually money rather than, or political ideologies or whatever. So you don't really know how this comes into the data that they provide. However, they are on the ground. You know, they can process the image in front of them that they see and provide you with some sort of data, and so potentially we could use this to try to improve the image data. As I say, unfortunately, the project itself was rather slight, so the actual outcomes of each of the demonstrator projects, I think, weren't so conclusive. I'll skip the engagement with communities one. So this was my attempt to basically answer the 5 questions that we were presented with. So obviously the heterogeneous data sources, that the whole point of the project was to try to say, can we combine the citizen data with the Earth observation data? And as I said, I think this thing offers a possibility, but there are a lot of problems involved in it, and it very much depends upon the use cases that you have and how you use them. I think this is particularly pointed because there's quite a lot of EU projects which are involved in this, and it's not an easy thing to do. Yeah, and you have to consider the user needs. So in our case, I guess it wasn't really clear who the users were. I mean, we considered the users to be the citizens themselves who wanted the data, and in order for them to give the data and use the data, you have to work out how to inspire them, or how to incentivize them, and that was very clear what came out. In terms of the questions 3 and 4, to be honest with you, I have no real idea how it links into Inspire's compliance. And in terms of the ability to use this in different sectors, I think that, you know, that crowdsourcing has been used in a lot of areas, some more successfully than others. So we have a number of projects along this line, and actually there are fields like mobility where again we've incentivized people by providing them with cheaper insurance, and we have other projects that involve football, and everyone loves to talk about football, and for those sectors we can get really good data. But obviously for land use, maybe that's a harder use case. I think that's it. Okay.
Thank you very much. I think many of us has been struggling with getting data for validation or production, and for sure crowdsourcing could be one solution, but there are challenges as you clearly demonstrated. There's already a question down there.
Hi. Yeah, I think it's important to be honest about these things because citizen science is a very trendy thing, but it's very difficult to find cases where good scientific monitoring comes out of citizen science. I'm thinking of two examples. There's a jellyfish monitoring network of citizens along the Belgian coast, and when they see a jellyfish, they report it, and when they don't see a jellyfish, they generally don't report it. So it's very difficult because, as a scientist, you don't have that zero data of absence when they're not there. And when they do see them, sometimes they invite their friends and family to take extra photos as well. So it was very difficult to use that data scientifically. And a second example in the United States where citizens were used to measure water quality in remote areas. And I asked my colleague who was very enthusiastic about what the role of the humans was there. And his answer was that the role of the humans is to transport the instrument. Whereas if they could just set up webcams and have the webcams running all the time, they wouldn't really need the citizens to do this. So it seems to me that there's enormous value, educational value in these projects. It involves people to think about the environment around them, but there's very marginal utility for scientific monitoring.
Is that it's quite hard to engage people unless they have a passion for it before you get there. And people generally aren't that excited about water, it turns out. So, yeah, but there's not enough people. That's the problem. And their excitement about water generally is quite variable. And so what you generally find with the projects is that you can engage people, and they may be engaged for a day or a week, even a month, but unless they have a focus which is basically they work in water or they do it every single day, then you're not going to find that they get bored or the process whereby they provide the data is not something they do on a daily basis. And so the way that we found these things work best is if you can collect data as a proxy. So things like we provide people with a way of measuring their speed of their walking or something like that. And actually, in providing that data, it gives us other things. It gives us some information about where they're walking, and then we can infer the land use in those places. And so it's kind of like we have to trick the people to give us the data. And it's a very hard problem. No, it's things like mobility data. So we want to know where people are going, where constraints are, things like that. And people won't provide us with that data if we ask them that question: where are you going? You know, is this a constrained sort of place? But if we can kind of cheat the data out of them by providing them with a service that they want, and as an opportunistic thing, get the data that we want back, then that seems to be working a lot better.
Okay, thank you very much. There's also a chance to continue on or a cup of coffee afterwards. We need to move to the last presentation of today. Now we will hear about forest resource mapping. and it will be presented by Mika Karjalainen, who is a senior scientist at the Finnish Geospatial Research Institute, and he has been the principal investigator for several Earth observation projects. So, Mika.
Thank you very much, Henrik, for your kind introduction. So, my talk is about 3D remote sensing technology and in mapping of forest resources. And at the same time, it is also a presentation about this advanced SAR project, which is funded by the EU in the FP7 space 2013. And in this project, we have 4 partners. We at the FGI, we are the coordinator and also doing some of the hardest tasks of the research. But then also we have on board 2 universities in Sweden and 1 university from Austria. And then we have an Irish company, 3Metrics, and they are basically thinking about the possibilities or exploitation possibilities about the outcomes of the project. So we are now on the 3rd year of the project, and we are still 1 year left to accomplish the tasks. And at this point, I would like to emphasize that this is really a science and research project. We are not directly implementing Inspire, or we are not creating new Copernicus land services, but we are creating new technology and new tools and new methodology that might lead to a new Copernicus land service at some point in the future. Yes, forests, they are of really high importance. First of all, they are a source of wood material. Then some people are talking about bioenergy, and of course they are related to carbon sinks, and of course they are a way of people are using forest in other purposes like hiking and for recreational purposes also. But from the remote sensing point of view, there is kind of a change in paradigm at the moment. At the moment, forestry people doing work with the Earth observation data, they are talking about 2D satellite images like SPOT and Landsat, and how these type of data can be used in forest resource monitoring. But what could be the potential technology in the future? Most of the people that we are being involved, our user community, they are talking about 3D, because 3D is really the key parameter, or the elevation of the tree is the key parameter in forest resource mapping. So this 3D technology, it will be really a turning point in the forest mapping and the forest resource mist mapping. And yes, this is basically our research hypothesis. So by using all kind of 3D remote sensing techniques, we can create more enhanced and more accurate forest resource maps from terrestrial techniques to satellite systems. We are using laser scanners, airborne imaging, satellite images, SAR images, and all these techniques, they create 3-dimensional points, and we call them as a point cloud, and we are actually talking about point cloud ecosystem. And by combining all this kind of data, we can create this more detailed and accurate biomass and forest maps to users. And first of all, this terrestrial laser scanning, this will be the, we believe it will be the next great breakthrough in forest inventory. This terrestrial laser scanning, you can put it in a forest using this tripod, or better, you can put it in a mobile system and you can drive through the forest. But both these techniques, they really create a really high density, accurate point clouds that describe the forest. This is the second left picture there. And from this point cloud, you can create models that are used to describe the forest, like trees, the tree's trunk and the leaves and all of these parameters that are important. And out of these tree models, you can create the forest inventory parameters like tree height, diameter as breast height, and stem volume, and so on. And This is related to our EU project in that way that we are also coordinating a Euro SDR project where we are trying to compare all kind of techniques in the TLS and all kind of methods that are used in the forest inventory and trying to find what are the most or the best techniques for creating forest inventory parameters. So we believe this will be the next great breakthrough in forest inventory. With this kind of TLS and mobile techniques, we can automate the field surveys and we get a better accuracy and also reduced cost with the same effort. And then airborne techniques, they are also really important. We are talking about UAVs or airplanes, and techniques that can be used here are laser scanning, aerial images or radars. And all these techniques, they create also point clouds that describe the forest. In the upper left corner, there is a high density measurements of forest in Finland, about 200 points per square meter, so really accurate and really dense point cloud of forest. And with this kind of data, you can create almost a similar description of the forest with the forest, like the TLS, but more wider coverage. And the second one in the left, there is a radar profile over forest, so you get the really high response from the ground surface, but also you get the reflections from the forest structures, and this kind of information is also important or can be used for forest mapping. And on the right-hand side up there, there is actually a stem volume or biomass map created from the airborne images. So this is actually the standard way that forest companies are nowadays creating these forest maps. And when we are going to the satellite data, there are also techniques that can be used to create three-dimensional information. If we are talking about radar satellites, there is first of all this SAR interferometry in SAR, or there is stereo radagrammetry, and then there is stereo photogrammetry, like Pleiades system can be used to create three-dimensional models. And actually one of our partners in Sweden, they have also used Pleiades images to create these three-dimensional models. But as you can see on the down of the slide, there is a profile over one forest site in Finland. So this ALS means the laser scanning point cloud, and yellow and purple point are from the satellite measurements. So clearly these satellite measurements, they are giving the information about the forest height. And if you know the terrain model, then you can easily estimate the forest height and also the forest biomass if you have the training data from the TLS systems. And actually this is one of our partners in Sweden, actually Chalmers University in Gothenburg and Swedish Landsbruck University in Umeå, and they have used this Tandem X. This is the German single pass interferometry mission, SAR or radar satellite, and from this data they have created a wide area map of forest resources in Sweden. And what is important here that this is actually really close to the same accuracy that you can achieve with the airborne laser scanning or aerial images. So this is really good result from the project. Unfortunately, this Copernicus satellite Sentinel-1 and Sentinel-2, they are not able to give you the similar type of information. And we are talking about success stories, or what could be possible success stories out of this EU project. First of all, this laser scanning, terrestrial or mobile laser scanning, there have been a high interest in all around globe, and actually we were a few months ago in Japan, and they were really interested of developing the similar kind of systems, and we have company in Finland called Solid Potato, and they are at the moment trying to commercialize this mobile system and this terrestrial laser scanning system to automate the test plots. And then we have a Finnish company called Sharpersat, and they are interested in power line mapping and vegetation mapping using this UAV technology. And of course, forest companies, they are really interested in, they are calling it as a precise forestry, so that before this machinery it goes to the forest, it also already has the accurate map of trees, and beforehand it can know the information how all these trees, how they will be cut, and what is the outcome, what kind of wood material is there. And this is really of high importance for the forest companies in Finland. Then finally some thoughts related to Copernicus system. Even though we have these nice and accurate terrestrial and airborne systems, satellites are still of high importance because they are the only way to map wide areas with frequent coverage. And that's the reason, because forests are, of course, in state of continuous change. There are clear cuts all around the globe, and in order to get the accurate information about the forest resources, you need to have up-to-date information. And the satellites are the only way to collect this kind of information. And these current satellites in Copernicus, Sentinel-1 and 2, they are not the best to map this kind of 3D information. And they are suitable for mapping forest area, but if you would like to go to the next level, not only know the area of forest, but to know what is the amount of trees or amount of biomass in the forest, you also need to know the 3D, you have to have the 3D information to get this information. And based on our findings in our project, for example, this German Tandem X system, it's really excellent for getting this kind of 3D information, and you get accurate biomass maps only by using this kind of 2D systems like Sentinel-1 and Sentinel-2. And actually what we have proposed to ESA is this Earth Explorer 9. So they are looking for new candidate satellites and they should have a result here by the end of this year. And we propose that for the Sentinel-1 we could have like a companion satellite that is flying together with Sentinel-1, similar than the Tandem X mission. And this way we could get this bistatic single pass interferometry, and we get this 3D information, which are very good for the forest mapping resources point of view. But also, even though satellite data is good for mapping, can be good for mapping forest height, but forest resources, there is always need for forest inventories or the field data. We need this to train and calibrate the estimation models. So to get the full potential out of these techniques, we need to combine all this. We need to combine terrestrial systems, airborne system, and satellite systems. This way we get accurate and up-to-date information and accurate 3D data. And maybe this will lead to enhanced Copernicus land service at some point of future. And also to create new European success stories and also new business in the forest sector globally. This can be like a success stories for whole Europe, as we are thinking about it this way. So thank you very much for your attention, and some questions.
Yes, indeed. Is there one or two questions? Yes. Yeah.
Hi, Dimitri from Even Flow in Brussels. Really interesting presentation, thank you for that. My question is, what do you see as the timescale for the broader, I'm not saying mass, I'm saying broader implementation of and availability of devices like, I mean, you mentioned a mobile LiDAR scanner. Do you see these, what's your feeling of the implementation timescale for these things to become more common in our daily lives?
I think these kind of mobile laser scanners, they are already like in a experimental systems, and I think it will be up to companies who are developing these kind of systems if they, on what time scale they are willing to commercialize the systems. But to my understanding, this will revolutionize the forest field mapping. I think it will take 5 to 10 years. So they will be really operational in the field.
Good, thank you.
Yeah, very interesting, thank you. I'm coordinating the FAST project, which is also an FP7 space project. We are looking to foreshores, and we are trying to establish from satellite Sentinel-1 and 2 information the biomass, which is posing some problems. You sort of are running into them also. So quite interesting, and I'm also, as a biologist, what we are doing now is we are sort of making a guess what a plant looks like. All the trees look more or less the same, and count the trees.
I
and
think
then we guesstimate how much biomass we have, more or less, but from 2D information. Eh?
Yeah. I guess from the forest or the paper company's point of view, they are interested really about the stem. And from these point clouds, you can quite accurately estimate the size of the stem and how it will be cut in the paper bush. And these other parameters, what is the biomass of the forest? Then there are these equations that you simply have the 3D point cloud, for example, like a diameter of 10 meters, and you calculate stupid 3D metrics, and then you have the model, simple regression equation, and you calibrate the equation with some training data, and when you have enough training data, you will end up with quite good result. So actually this estimation or prediction is really straightforward, and there is no intelligence there at all.
Okay, thank you.
Okay, thank you. Thank you very much. One last question, maybe.
In terms of, you have also mentioned that in situ information is still very important, and having other equipment in different ways of acquiring data on the field, counting trees and so on. Surely you must be using positioning there as well. And what are the main issues you encountered with specificities to Finland? Because it's quite up north, so...
yes, there are, first of all, there is GPS and GNSS receiver. This way you know the position of your mobile system. But then there is also inertial measurement system. And when you go into the forest, at some point GPS or GNSS signal will decrease, and you will start to decrease the position accuracy. And to some extent this inertial measurement unit can keep the positioning also. But when you go further, it will decrease also. And then there is a technique called SLAM, simultaneous location and mapping. So there is a one scanner making scans like horizontally, and you have 3 stems here and there, and with these measurements you can accurately co-register all the data. Yes, but for sure it would benefit if the positioning accuracy from the satellite systems are better, and we will see if Galileo system will help. Actually, in the FGI we have a strong group in the positioning systems as well.
Thank you.
Thank you.
Thanks. Okay, this was the last presentation. Certainly we covered a large variety of subjects. We've been talking about GeoGEOSS and Inspire, about PROBA and the exploitation platform. We have been extracting height information in urban areas from high-resolution satellite data. We've been talking about the synergies between, potential at least synergies between Galileo, Inspire and Copernicus, crowdsourcing and all the challenges involved, and of course also 3D mapping in forests. And I think what these presentations demonstrate actually is that there's so much exciting research going on, and hopefully one day there will be they will influence either, I mean, at the level of core services in Copernicus or downstream services, and by that I mean the data that we are producing in Copernicus will be used for new application, and that's really important. And we will have Inspire in a way as a framework that will allow us to discover these data and make these data available, and that also will allow us to get additional data to enhance the applications. So thank you very much for all these very interesting presentations. Let's give the presenters a hand. And then by this I will end the session, and I'll wish you a very nice evening in Barcelona.